Well, thank you very much for coming to this Lunch and Learn on the early days of RSNA 2021, and thank you for coming and traveling. Today, we're going to be focusing on Subtle Medical. And you can see the mission statement for Subtle Medical. It's a company that started in 2017 and has grown since then. And really the goal is to focus on AI-powered software that can make medical imaging more efficient and better for patients in a very global sense. So not only be something that can help you with your workflow, but may also make the patient experience better and perhaps also let you do more with your imaging in the future. So, I should introduce myself first. My name is Greg Zaharchuk. I'm a neuroradiologist at Stanford, and I'm one of the founders of Subtle Medical. We're very lucky to have a wonderful group of speakers here today, and you can see their names here. Krissa Paraskevapoulou is here from Afadia, one of the largest radiology enterprises in Europe. Larry Tanenbaum is here from RadNet, and he's going to be our moderator for this event. Amish Doshi is a professor of radiology at Mount Sinai, and Ravi Jain is attending at Middlesex Health. So they're all going to talk, and they'll be much more eloquent than I will be. So first, I just want to give you a few updates on what the company's been up to over the last 2 years since we've last seen you. So Subtle Medical is the leader in vendor-neutral image enhancement, and what that means is that we use AI basically to improve the image quality and efficiency, which is in a vendor-agnostic way, so that if you have older scanners, if you have multiple different kinds of scanners in your fleet, this can be used for all of them. Since the last time we spoke, we have 2 new FDA clearances and CE mark as well. So SubtlePET 2.0 extends the original SubtlePET software, which was able to reduce imaging time or imaging dose by up to 4 times, from FDG and amyloid imaging to include newer tracers that you might be interested in. In particular, this is an example of gallium-68 PSMA, so if any of you are doing prostate imaging, this tracer is now FDA cleared for SubtlePET. So SubtleMR also had an overhaul. A 2.0 version. If you recall, the very first version was focused on neuroradiology, where many of the procedures are, but we realized that many other segments could have value for imaging in a more efficient way. And so SubtleMR 2.0 actually focuses on the other, basically 99% of all possible procedures you might want to do. And this is just an example here. I'm going to say this is the hip, but I'm a neuroradiologist, so you can correct me if I'm wrong. TMJ, according to one of our fans. No, that much I know. All right. So as well as FDA and CE mark, we're also cleared for use in Canada as well. I just want to highlight some of our global customers and our partners. We're running currently on 120 scanners deployed globally, and we've saved about 700,000 minutes. And I thought to myself, that sounds like a lot, but how much is that actually? It turns out that that's 486 days of people's lives that they've been given back to them. Because nobody, when they're sick, wants to be in the scanner any longer than they have to be. And of course, as an imaging facility, you don't want to have people go through that. So we're almost, almost 2 years, a year and a half of saved time for our patients. So we're very proud of that. We've also spent a bit of time publishing, and we want to thank our collaborators as well as the Subtle R&D team. They've really been pushing the envelope of what's possible, and some of the articles that we've co-authored together are shown here. I want to highlight a couple words that are in here frequently, which is multi-center and multi-reader, because we think that these kinds of studies, particularly prospective studies, are really the studies you want to see to prove that the AI quality that you're getting is sufficient. So just, you could take a look at those. We're happy to share some of those with you as well. We've also been partnering with industry leaders, and I want to highlight a couple of the partnerships on this slide. We announced today a major partnership with Bayer Healthcare that's centered around reducing gadolinium dose. And we'll talk a little bit more about that in a few minutes. We are also the first application to be integrated into the Siemens OpenAI platform. so that if you are going to buy a new Siemens scanner, you have the option to run Subtle inside. And we've also partnered with AIDoc and Cortex, both of whom have a lot of synergy with what we are doing. So we're very focused on upstream AI. These folks are the leaders, I think, in the downstream fields. Okay, now I get to talk a little bit about sort of what's on the future roadmap. So, I feel always that MR and PET are really the low-hanging fruit. They're the most inefficient of imaging modalities, the most expensive imaging modalities. But there's plenty of things that one would also like to do with deep learning and one can do with deep learning. So as you can see here, over time, many of you are familiar with our work on subtle gadolinium. We are expanding into the SPECT and PET spaces, as well as fluoroscopy. I'll talk about that, as well as QC. So first up, a little bit about subtle GAD. We were lucky to have a large NIH SBIR grant to work on this over the past few years, and this has really led to this close partnership now with Bayer to really examine a combination product. So to actually use a lower dose of gadolinium, in this case 90% reduced gadolinium, and to actually enhance that with deep learning to improve the quality to a full diagnostic dose. This also improves the patient experience. I think many patients that I meet are always interested in whether they're getting gadolinium for their study or whether they can reduce it. So this is really an option for those people as well as people who need frequent follow-up. And the last thing I just want to comment on gadolinium that sometimes we forget about is that gadolinium is actually increasing in our wastewater, and actually it's increasing quite significantly around centers that do a lot of MRI. So I think that the reduction of GAD is not only good for patients, but it's also good for the environment. SubtleIR is another technology that we have been working very hard on, and were recently awarded another NIH SBIR grant. And this essentially uses deep learning to improve the image quality of low-dose fluoroscopy images. So as you know, to do fluoroscopy, one is obviously radiating the patient in real time. And this leads not only to dose to the patient, of course, but perhaps even more important, dose to the operator, because the operator will get that dose every day. And in fact, if their badges go too high, they have to stop. So it's very important to reduce dose in this setting. The other thing about this product, which is something a little different from the products we've had before, is that this requires real-time processing. So this requires the ability to run at 30 frames per second. So your AI needs to be optimized to do inference, not just, you think 1 second and get an image is good enough. Well, you have to do 30 times better than that for fluoroscopy. So that's what we've been working on in that space. And then finally, I just want to share briefly some of the sort of further out ideas that we've been working on and give you a little taste of what we're interested in. The first is SubtleSynth, which is the idea that we can take imaging that you're already acquiring and essentially synthesize contrasts that you might also want. So I like, within the company, I like to call this 100% speed up, because essentially you can imagine taking images you're already acquiring and just producing an image, and you can use that image to replace getting an image. You may want to use that image if the image that is acquired clinically is motion corrupted, for example. So this is a very exciting area. We are very interested in SPECT. SPECT, as you know, is a growing field, and we've got some preliminary data and work going on that shows very significant dose reductions in this space. Actually, SPECT has one of the highest doses of any of the algorithms that we use. So we're very excited to pioneer this for our patients. And then finally, we're very interested in using this technology not just to enhance the quality of images, but to use those images in a smart way. So I don't know if any of you had the experience when you're reading a study, or you read a study and you see 2 perfectly good scans, and you're like, well, why did they repeat that scan? That was a waste of time. And then also you see a terrible study, and you're like, why didn't they repeat that study? So something that will flag high quality exams and lower quality exams, and then you can set that as however you want for your particular organization. You can kind of take that and standardize that across all of your scanners so that people will have advice on when to scan and not to scan, and they don't have to bother you as a radiologist. So these are the things that we're interested in. And at the end of this presentation, please join us in In South Hall A, we're going to have a latte bar, so it's kind of a nice thing to have right after you've had a big lunch. You're probably going to feel like you want to go to sleep, and you can just come down and pick up a latte with us. All right. Well, with that, I'm going to get out of the way and introduce our moderator, Dr. Lawrence Tanenbaum. Many of you probably know him. He is the Vice President, Chief Technology Officer, and Director of Advanced Imaging at RadNet, which is, obviously one of the largest companies in the U.S. Focused on imaging. His credentials are shown here. He has done lots of great work for ASNR, RSNA, ESN, and ISMRM. So without any more ado, I will pass the microphone over to Dr. Tanenbaum. So thank you.
Thank you for that introduction. That's actually some pretty exciting stuff that you showed there. My perspective is a little different from most, having spent 20 years in private practice, 8 years working for Amish Doshi at Mount Sinai, and now 7 or so years working at RadNet, which is a large imaging chain. We have 353 or so outpatient centers that are fighting the good fight, and a lot of those tools that you talked about in terms of works in progress are right up our alley. Avoiding repeated exams, repeating the right exams. If only we could use 90% fewer needles, we'd really win the contrast war. So I love what I saw there. But my presentation today is going to be on where we are now and hopefully set the stage for some of the other speakers and some of the opportunities that this technology brings. So we'll do a little bit on what is AI, because no one can resist. We'll talk for a second on presence in society. We'll talk about where AI impacts on the imaging enterprise, but we'll focus on the benefits in image reconstruction, and we'll try and take this all the way down to the level of what's the return on investment, because for all the wonderful things that Subtle does, they're not giving this away. So it's important to know that you can make a good financial case for this, aside from the benefits in terms of patient impact and the like and better experience. So we know what AI is. It's essentially using computers to do things that are associated with human intelligence. As you can see from this chart, between big data analytics, an innate machine learning tool, and what's listed as AI here, it's really the dominant technology we see in healthcare today, and you can't miss it out there in the booth. As a matter of fact, interestingly enough, RadNet is immersed in the AI section, which tells you a little something about our focus as a company. But as you know, it's all around you. It's everywhere you go. And we're all familiar with some of the achievements that AI has. Autonomous driving, works until it doesn't. Defeating experts, actually really the easy thing to do for a computer to beat an expert at chess and go. But harder things, easy things are hard for AI. Hard things are really easy. It's everywhere in online advertising. I can't open up a browser where they're getting advertisements for Wagyu beef and 00 flour. It's essentially been described as something as ubiquitous as electricity. Now, this chart from you, Harvey, which is great, and really, this is from a few years ago. It was a really nice chart that really showed essentially the full spectrum of what you can do with these tools. I'm going to have to use a pointer here. I think I can use that. There. So you can see this can be used for everything from utilization management to follow-up management. We're not going to talk about any of these things. We're going to focus on really this little piece right here where we can reduce scan time and reduce dose, as you saw from Dr. Zaharchik's presentation. So when it comes to image reconstruction and machine learning and ultimately deep learning, there are several tools that are out there that are making a difference every day. One is compressed sensing, which is essentially reconstructing images from very sparse data, and you can see you can do things as remarkable as reducing your scan times in half. RadNet probably has 60 scanners running MRI of the brain in 2 minutes and 12 seconds as opposed to the old 5 or 6 minutes. It is something we just plug in and walk away, and it just looks exactly like it did before. There are tools like iterative reconstruction. We know iterative reconstruction from CT, right? Reduces the dose, changes the image a little. You could do iterative reconstruction for MR and save a little scan time. On the other hand, when it comes to true deep learning, I think we have some real opportunities there. And this is an opportunity to look at essentially all of the benefits and the spectrum of benefits that we have in these circumstances. Essentially, these tools can optimize your scanning. So it can actually maintain or actually elevate image quality despite the fact that you're scanning shorter. You actually can use this as an opportunity to improve resolution, signal to noise, and contrast to noise. I'll show you examples of all of these. You can enhance the patient experience, the staff experience, even the radiologist. How does the radiologist experience get benefit? When you look at an image that is pretty, It has high curb appeal, low noise, your stress level drops. I like to use the example of the soundproof headphones on the plane. Why do we wear soundproof headphones? Because that noise barraging your brain is just going to stress you out. They've shown that people who live in airport flyover zones, their EEGs change when the airplanes fly over. So whether we perceive it or not, noisy images stress you out, okay? And that's where the radiologist comes in. The curb appeal of the image certainly affects referrals, but it also affects the way you feel about what you're doing. But all of it is important to consider that it's going to preserve the integrity of the image. And this is where deep learning beats everything else. It has been shown that deep learning reconstruction doesn't change Hounsfield unit values. It doesn't change other quantitative values like fractional anisotropy values. And Dr. Bash, sitting here in the second row, showed it doesn't affect the veracity of your quantitative brain measurements for things like quantitative neuroimaging. It essentially lets your systems outperform their limits. You got an old system with 4-channel coils, or you don't have a great coil for that application, this tool will actually help. You have a system that doesn't do a lot of accelerations, it doesn't bring you, it doesn't have a digital RF chain, this tool will actually help. And essentially it allows you to dream with thinner slices and higher matrices. I've seen these tools make a 3T look like a 7T, or a 1.5T fight competitively against a 3T in the environment. Now you're here at the RSNA, right? So you know all the vendors are offering things on their new systems, right? GE's got Air Recon DL, actually changed the industry in my opinion. Siemens is delivering Deep Resolve. They have Gain and Sharp today. They'll have Boost next year. But as you've seen, they're also partnering with Subtle. So why is Siemens partnering with Subtle? Because Siemens tools for the near future are only gonna work with 2D Cartesian fast-spin echo. It's a lot of other stuff we do on the scanner other than 2D Cartesian fast-spin echo. And that's why a tool like Subtle Medical, which can do everything, essentially, is an interesting add-on to their offering. They will have a deep learning reconstruction second quarter. That's pretty exciting. But again, on their newest systems, not on the legacy systems. We have roughly 2/3 of our systems are legacy systems. We are not going to be able to upgrade all of them in a day. These tools can help. Philips is delivering Smart Speed now. Their true deep learning reconstruction will come out next year. And Hitachi has, a form of image acceleration they call IP Recon. If you want to get a sense of, by the way, the science and the didactic behind this reconstruction, you can check out Dr. Bash's article here in Applied Radiology last year, which really talks about these issues. So really, we're here to talk about SubtleMR, which distinguishes itself from the OEM offerings in being broadly applicable, not just 2D fast-spin echo. Okay, DICOM-based, which essentially means it is vendor agnostic. It can work on anybody's images. And true deep learning reconstruction, which makes it an advance over the stuff you heard earlier. And again, it works on legacy systems. And you'll see these images over and over again. Essentially, it can take an image which used to take 3 minutes and 3 seconds and emulate that quality in 1:36. We accelerate the image by doing all kinds of things that ordinarily affect the SNR, but use deep learning to get back to a quality image in that circumstance. And again, our goals are not to match the image quality. Our goals are to go just enough higher that when we show the radiologist you can have this or this, they go for the one that's affected with deep learning because we've leveraged some benefit to go a little bit higher resolution. And again, saving reasonable amounts of scan time. Yeah, I don't want to steal the thunder of most people, but you can see the standard of care and then what an accelerated image with the subtle image processing goes on there. It's just maybe a little bit better in these circumstances. Now, I got to put my glasses on. This was a paper that was just accepted in clinical neuroradiology, which looked at using this software to accelerate spine images by 40%. The reviewer said, how'd you come up with 40%? Well, we just took a shot. There's no science behind 40%. Maybe you can get 61%. Okay, but we tried 40, and we showed that this stuff worked, and it was just accepted for publication. It hasn't come out yet, but you can see basically this type of an approach. Here is the standard of care image, little schwannoma over there. Here is what happens when we accelerate the image. We've introduced more noise, but gotten a faster scan time. And with 40% less scan time than that, we're able to create this image. And that's really the whole process here. It's the same thing here from the same study, in the same research study. You see, when you go faster, you start to introduce more noise, more salt and pepper. Salt and pepper is good for a brisket. It isn't really good for a medical image. You can also do things like this, which is really cool, using a super resolution or a resolution enhancing technology. Here you see a typical 30-slice flare study, which we're cranking out in 99 seconds. Okay, if we drop the spatial resolution, we get down to 43 seconds. By the way, the SNR had gone up. Even the contrast to noise has gone up. I'll actually prove that to you a little bit later. I'm sorry, on here, so I meant to say that. And then we can actually use this resolution enhancing technology to get the soft image to go there. Now, you're comparing these two in substantially less time. Now, we've done this, we actually did some work in 3D on this, and this is our clinical 3D flare, and you can see that it's a little noisy. Why is it noisy? Because we're trying to make it isotropic, and we don't have that much time. If we do a lower resolution version of that, you get the SNR goes up, maybe even the contrast to noise goes up, and then you can use this resolution enhancing technology to do this roughly a third faster and get this type of quality. Clearly better than what we had beforehand. This is one of my favorite examples because it's something that I saw first with this case, but now I've seen many, many times. Gorgeous looking clinical standard of care, an accelerated image which throws away some spatial resolution. The resolution enhancement brings it back probably to a better state than here, but if you look inside this circle, there's a lesion here, there's a lesion here. It's hard to see here. It's kind of lost in the noise. The noise level here has blunted my contrast to noise, just enough that I don't see that. But you can see what this inherits is the contrast to noise of the low-res scan, the signal to noise of the low-res scan, but the resolution, in theory, of the high-res scan. Now, again, we talked about quantitative integrity, and this is where Dr. Bash's paper, which was just published in AJNR this week, so it just came out, I don't have the full DOI number here. Well, she did the same thing, went for a 60% acceleration of 3D T1 weighted images and said, what about the quantitative integrity of these images? By the way, Ann Minnie pointed this out as the image of the year. Thank you to anybody who was on the panel who voted for these images. And it was actually a semifinalist for paper of the year. But what she showed was the numbers were the same, whether they did it with a 40%, 60% acceleration and processed it, or just did it the standard way. And by the way, Dr. Bash is doing a presentation in the AI Theater tomorrow, and you'll get her full perspective on what she's done. So what these tools essentially do is give you the opportunity to virtually upgrade your systems. You know, if I had all the CapEx in the world and had no operational issues, maybe I'd upgrade 200 systems next year. That's not going to happen. Okay, so it essentially lets me take my legacy systems, GE, Siemens, Philips, Hitachi, and essentially boost their quality. Okay, maybe it makes them match a competitive system. You know, we're getting hammered by somebody with a new 1.5. Can we make our 1.5 quality match theirs? Maybe I've got an old 3T sitting next to a new 3T, and now my doctors don't want to use the old 3T. Okay? Those are the things that I see in my administrative position, and this is a way to answer all of those. But most importantly, it allows us to improve standardization and consistency. My national medical director came to me today and said, our biggest problem was we have all these old systems, and they're all running different protocols, and the inconsistency is driving us all crazy. Well, I said, you know what? We now have Subtle Medical rolling out in 30 systems now, soon to be 200 systems. And as we roll out the standardized protocol for HDX, you know, for Skyra, for Esprit, you know, they will all be the standardized and the same. Big benefit across the board. I like this example just to show it's not neuro, it's not your grit, it's not Subtle 1.0, it's a whole body system. It's not just turbo spin echo, it's everything. You can see we've taken an image that we've made corrupt by going fast. Look at the bladder, see all that noise? Okay, comparing it against the standard of care, and actually, in my opinion, at least in this case, a better version in actually a third of the time, which is really what you're after. So this is what we're doing every day on our systems. This is 7-minute, 9-minute knee. Can I do better on some systems with deep learning reconstruction, with 16-channel coils on a brand new $2 million scanner? Yeah. But, you know, I have 200 systems that are operating at a much lower level than this, which much lower efficiency, and this really, really helps. Here's a, you know, 7-minute and 12-minute, 7-minute, 12-second full lumbar spine scan. Okay, it was a lot easier, by the way, to get the neuroradiologist at Sinai to accept a little less in the spine. We didn't do these top-to-bottom scans, but at RadNet, you know, I'm just an administrator, so I don't have that kind of influence. You can see 5.5-minute thoracic, 5.5-minute lumbar. You know, brain with and without in about 14 minutes, so easily fitting in a 20 to 30-minute exam slot. The epilepsy study that blows up everybody's schedule, okay, is now done in 13 minutes. It's pretty impressive. So, you know, we actually ran pilots at the beginning of this evaluation. How did we decide? We ran pilots, and we just went in, and none of the administration got involved. We said, we took the Subtle guys, we took our section leaders, we had the meet and craft protocols. And at the end of the protocol trial on the East Coast, I think I lost my pointer. My pointer's not working, right? You can see it here. You can see the kind of reductions we were able to achieve and the kind of net scan times we're able to achieve. That's in the East Coast. Different doctors in the East Coast and the West Coast. You can see that our East Coast radiologist made some pretty compelling statements. Faster scans, better image quality, less motion. Gee, those all seem like good things. Visually appealing. Okay, better analysis of chord signal. And a really nice interaction with these Subtle folks. They really are nice folks, good friends of mine. What about the administration? He's getting pushback. We don't want to use this scanner anymore, okay? Yeah, like we can, oh yeah, we'll turn it off for you, it's no problem. We'll keep paying the service and the tax, but we won't use it. That doesn't work, okay? Poor image quality, stop doing cases, okay? As soon as you put the software in, the complaint stopped. Volume also improved, okay? How do you justify this? Volume also improved. Here's the West Coast. Here's the scan time reductions. Here's the net scan times. These aren't old legacy systems, by the way. This is not the system you're going to go pay Siemens $3 million for right now. Old legacy systems. And what does Dr. Bash say, who is our key interface on all the stuff we do on the West Coast for advanced neuroimaging, quantitative neuroimaging, and certainly AI-based neuroimaging? You can see her statements here: maintained image quality, optimized protocols, boost in sharpness, better signal. It all sounds pretty good. But let's just say that you love the idea. How do you get the administration to do it, right? How do you figure out what it's worth? What's the cost-benefit analysis? Well, the first option is, do I upgrade this system or do I virtually upgrade the system, right? If you upgrade, you have to have your CapEx. Kind of tough coming out of COVID. Kind of tough when CMS is constantly ratcheting things down. And by the way, construction just kills our numbers, right? The way downtime kills our numbers, and all of our administrators are numbers oriented. It's like everybody in the industry is numbers oriented, okay? And by the way, you put a new scanner in, all of a sudden the service price goes up, and the payments go up. There's a lot of cost associated with a virtual upgrade. You keep your lower service price, okay? You don't have to find the CapEx. You just have to pay somebody for the software subscription. Well, that's a problem. Yeah, but we'll figure that one out soon, eventually. So if you could imagine how those benefits could benefit you, you can see, if you were working on 20-minute slots, as we do in New York, you can get to 15 minutes, as long as you have good patient workflow. That's 33% more throughput, okay? If you're at 30 minutes, like many, many people are, you can get to 20 minutes. That's 50% increase in throughput. So, very conservatively and very vaguely, these don't really reflect RadNet numbers because, we did a lot of negotiation from this particular point, but we figured out that based on roughly what it costs you to do this on your scanners, and the benefits that you can glean in reality from putting this on your scanners, the ROI was roughly 6 times in the favor of the buyer, okay? And that's not a terrible thing. Assuming that the only thing that changes in your cost is DL recon. Now, mind you, one of the biggest challenges that we have, and I'm sure that universities have, and people have around the world, is it's very hard to find technologists these days, right? Because people are leaving this urban flight caused by COVID. There are a lot of people who have retired who said, look, this is a good time to retire when everywhere you turn there's another virus that's trying to kill me. And then vaccine mandates, right? That has taken a lot of people out of the workforce. So if you just shorten the hours with the same staff that you currently have, that has an enormous benefit. So ancillary benefits, I've kind of covered those. But other things, if your scans are shorter, you stay on schedule. By the way, if you had a tool that told you what to repeat and what not to repeat, which is one I've been asking for, I think, since the day I was born, okay, that could also keep you on schedule. Patient satisfaction, obviously benefits. One of the things that RadNet lives on is customer satisfaction. I'm fighting Amish Doshi for every patient every day. Every time, Noah Syndergaard came out in the paper and said, I was in that MR scanner so long in special surgery, it exacerbated my injury, okay? Patient-focused care. Get me off the table in 15 minutes, okay? And I won't be complaining on the front page of the New York Post that you hurt me by keeping me in the scanner too long, okay? Patients want to get out of the machine. Again, and all the other things that we talked about. All right, so essentially, we talked about how these tools can really affect what you're doing. optimizing and harmonizing and patient-orienting all of your systems. We are actively engaging in rolling this out. It has been a relatively seamless and productive process. We have them on 30 systems now. You know, by the time we get to the ASNR for the neuroradiologist, we'll probably be 200 systems. And we will continue as we integrate new scanners, put these things on. So it is a very, very big deal. Again, if you're looking to see some of the concepts behind what I said with a little more didactic and backup, you can find this article that Dr. Bash and I wrote in January of this year in Applied Radiology. And I hope you appreciated that very fast and sort of eclectic sense on where we are with image reconstruction in our practices. So thank you for your attention. You know, it's a funny thing. I take a certain amount of pride in the experiences that I had in academics and otherwise in mentoring people. And Amish Doshi was my fellow. I'm not going to say I mentored him that much, but within a couple of years, he was my boss. You know, I would think that's a pretty good example of success. Amish Doshi is a great friend of mine. He is obviously a radiologist at Mount Sinai. He is also the chief of the Division of Neuroradiology and associate professor. Since then, he has picked up a number of other very important titles, like vice chairman of ambulatory services, chief of the Division of Neuroradiology, I already said that, and associate director of the radiology residency program. And he's going to take us through the Mount Sinai experience. Dr. D.
Thanks, Larry. What I'm just going to try to do today is talk about our experience with Subtle and kind of the practical approach that we took. So, you know, obviously Mount Sinai Hospital in New York City is a large academic institution. We do over 1.5 million studies a year. We have inpatient and outpatient sites. You know, MRI is performed at most of our sites. We have about 25 MRIs in the system. And as Dr. Tanenbaum mentioned, you know, one of the issues that we have, right, we have new and old scanners, different vendors across the systems, and we're working with different software platforms. So what are our challenges with MRI? We're experiencing increasing demand, and I've heard this from many of you, many of my colleagues in radiology, that, you know, pre-COVID, you know, we were busy. During COVID, really the peak of COVID, volumes definitely were affected. You know, people weren't coming in. And all of a sudden, there was a big bounce back. And there's multiple studies that have actually shown that, that we've kind of come back to that level of pre-COVID, if not even a little bit higher now. So there's definitely, you know, issues with capacity, right? So we've experienced this all the time with our hours of operation. We run 7 days a week, but not all of our scanners run. You know, we don't have the staff to actually cover all the scanners. Dr. Tanenbaum mentioned this as well. And of course, there's increasing pressure on our staff and technologists, right? So everyone's saying, get my scans done, get them in, and they're all going to RadNet instead of Mount Sinai. So we gotta figure out how to deal with that. Certain solutions, of course, increase capacity. We can get more scanners. That's going to be costly. We can get more technologists. They're hard to find, though. Upgrade the scanners, too. You know, we get faster scanners, add compressed sensing, other things some of the legacy scanners or the old scanners don't have, right? Even add AI, but it's very, very costly. And the goal is, right, to decrease MRI time. Enter SubtleMR, right? So this is something we started using. It's vendor agnostic, so we can, of course, use it against all of our scanners or any of our scanners. It helps decrease imaging time. We were able to maintain imaging diagnostic quality, which is obviously very important. And we actually started with brain, spine, and knee, and that's currently where we are right now. We're in works to expand it to Subtle 2.0, and we should be doing that shortly. But I want to talk to you really about our experience with brain, spine, and knee. So really, how do we evaluate and implement this, right? So we're really comparing our conventional scans to SubtleMR reconstruction, changing the parameters as needed to obtain really what our desired quality and scan time is. And so how do we do this? We typically evaluated one sequence at a time, whether it was a brain, spine, or knee study. We took about 10 or 15 patients. Obviously, we don't want to run everything because it does cost you time to run the Subtle sequences against conventional sequences. So we would review each of those scans with our stakeholders, which were our neuroradiologists or MSK radiologists. and then go back to the team, the SubtleMR team, and discuss how we could optimize certain sequences if we didn't feel that they were up to speed or at diagnostic quality. And then we would implement once we got to the result that we wanted. So this is an example sagittal flare sequence. And you can see just definitely a little bit more noise here. This was the initial one. We went back to the Subtle team and kind of commented that we did feel that there was increased noise on this. So they went and they were able to use the same data set, go back to the algorithm and then revise it, produce again, a faster quality, high quality scan that we were much happier with. Similarly, there's different sequences where they can change parameters, decrease the matrix size and the phase encoding direction in this case, and where it would affect your resolution, and use their super resolution algorithm to get a very nice scan with some time savings. And this is a denoising algorithm on a sagittal T2 of the spine. Dr. Tanenbaum showed this as well, where there was a reduction in your averages from 2 to 1, and you can see a pretty significant time savings. And in the image quality, I can't really tell the difference. So they look equally good to me. We looked at this, our team looked at this. We actually compared in our lumbar MRIs, the sagittal T1, T2, and STIR imaging. 2 of our neuroradiologists reviewed this for diagnostic quality of osseous and extraosseous structures. We just used a basic nominal scale, whether we thought it was usable or unusable. And there was very good intra-observer agreement. And we found no significant difference in diagnostic quality or legibility between the conventional and the subtle scans, and very similar artifacts. So once you have acceptance of scan quality and you have improvement in your scan time, how do you actually implement this to effectively realize the gain? And Dr. Tanenbaum mentioned this on kind of the ROI points that he made. And certainly we found differences in opportunities and challenges in the inpatient and outpatient side. So initially, I felt that the inpatient side was primed to use on the inpatient side, because you have sick patients, you want to get patients through the scanners quickly. We did find this to be actually a challenge, and it's because on our inpatient side we have non-standard protocols. Every patient's treated a little bit differently. Different pathologies are looking for different things. Maybe a patient's going for surgery, and we have specific preoperative imaging that needs to be done. So we're constantly adding and modifying sequences. So it's very difficult to actually operationalize the subtle imaging on the inpatient side. And also, patients were less cooperative or sick, so we couldn't really perform that evaluation period. They want to get patients off, so we weren't able to really evaluate the conventional against subtle. Where we did find a big help is at Sinai. One of the things that we do with spine surveys is that we always check for axials, right? And one of the challenges that we always have is our techs are constantly trying to reach out to the neuroradiologists. And if we're out of the room, it could be 10, 15 minutes before they get in touch with us. Not ideal, of course. So this is one area that we actually use Subtle to really help with this. We were able to run the sagittal sequences and the axial sequences through the Subtle protocol and actually save time on the overall imaging of these patients, because it really eliminated the need for an MD to check, because we were getting axials throughout the entire spine. And so you can see that the image quality was maintained. These are 2 sagittal images, and you can see that there's reduction in the number of averages. And the overall protocol, you can see that there's a pretty significant time savings between the routine sagittal spine survey and the subtle sagittal spine survey. Outpatient imaging is where we've really found the lowest hanging fruit, because again, protocols were standardized here. Every patient was pretty much getting the same types of protocols, and we had some flexibility in scheduling, so we could actually look at where specific exams would be directed to, and I'll explain that in a moment. And certainly patients were more cooperative, right? Less sick patients. Our initial implementation, we had an on-site server rather than a cloud-based solution. One of the challenges being in a large academic institution is to get things through the system. The Subtle people recognize this, so we really wanted to get started with this, so we had an on-site server, and we ran the conventional and AI sequences, and as I mentioned, we evaluated a number of cases, and we got a consensus review for adoption and then conversion to the AI. And we saw, and Dr. Tanenbaum had mentioned this, very similar reduction in time for brain protocols and lumbar spine protocols. We got a 46% reduction in our lumbar spine protocols. And you can see overall, when we kind of take our group of brain imaging that we performed, you can see the differences between where we're using AI, the Subtle on an MRI, compared to an MRI that was not using Subtle. And you can see a significant time difference, definitely decreased times across the board when we're using Subtle. Same thing with spine, even more so. You can see really significant improvements in the amount of time that these scans were taking. So what we did really to kind of see if we could get an ROI with this was we of course reviewed the scan time improvement, but we engaged our scheduling, right? So what we did was we really wanted to look at how do we take the time savings and improve our scheduling, right? Improve our slots. And this, Dr. Tanenbaum mentioned this. We really looked at how we can go from doing 2 scans an hour to 3 scans an hour. And we really focused, because we were really working on brain, spine, and knees, we took those exams and we directed them through our scheduling system into 2 specific scanners. And so we would fill those scanners with these exams that were running the Subtle MR. And we were able to really leverage the time savings to get that maximum 3 scans per hour. And that resulted in a fairly significant number of MRIs performed on those scanners. And you can actually see this was actually a nice table or graph here. When we implemented a Subtle, we saw an immediate increase in the number of scans we were doing. Our weekday volume for the month actually went up about 30%. So we really noticed a significant gain, and that's maintained throughout. So, and remember, we're directing these specific scans to those 2 magnets. So our experience has been that using Subtle has really improved MRI scans, and we really do feel that the image quality is equivalent, if not better, in the scans that we're doing. And we've utilized this, we've utilized Subtle to really help improve our throughput. It really helped it. So, just to give you an example, I asked our techs when we were really trying to evaluate whether we would move forward with an agreement, if we took Subtle off the MRs, and they said, don't do that, because that would definitely affect our workflow. So I'll leave you with that. Thank you.
I'm going to take some executive privilege and ask each of our speakers a question as it comes up. So, Amish, you mentioned the inpatient-outpatient thing, and I think it's potentially sending the wrong message that you can't use this in inpatients. What he was saying was he did the evaluation in outpatients because it's a lot easier to control. Have you had any success using these in inpatients?
That's a very good point. So yes, I mentioned spine surveys, but now that we've actually optimized our outpatients, we've really used the outpatient experience to then transfer it over to the inpatient side.
Yeah, I'd also like to point out when you saw Dr. Doshi's presentation, you saw a lot of brain and spine, and that's because we were working on Subtle 1.0 when we did these trials, and it didn't do anything more than brain, spine, and knee. But now it's applicable across the board. So when we're rolling this out to all of our scanners, it's getting head-to-toe coverage on all of those. Thank you, Amish. Our next speaker is Dr. Ravi Jain. He's a radiologist at Radiologic Associates of Middletown and Middlesex Health. He leads the nuclear medicine and artificial intelligence efforts at his practice. He hails from Caltech with an MS and PhD in chemical engineering, has 2 radiology fellowships at both Yale and University of Colorado. And I assume your skiing wasn't hurt either at your University of Colorado training. And lots of publications, most recently in radiology and imaging cancer, and the Journal of American College of Radiology, and previously others. And he's going to talk to us about introducing AI-based techniques in the community hospital setting. Dr. Jain.
Thank you, Dr. Tanenbaum. So, first of all, good afternoon to all of you. I'm going to talk about how Subtle products, sort of helped me in introducing AI applications at my community hospital, a small community hospital in Connecticut, actually. So this is not a technical talk. It is more about strategy, because it is very challenging to bring new technology to a small community hospital. So I came to the 2018 RSNA, and that year the AI showcase had made a big splash. And I remember spending the entire morning going through it. And initially in the morning, I was very excited about it because I was optimistic about the new AI applications that will help the radiologist in becoming more accurate and faster. But then towards the end of the morning, I realized that when I go back and talk to my administration about introducing AI, they will probably not be very supportive. Because first of all, they won't understand what AI really is. And secondly, because the AI applications that help the radiologist, they do not help the bottom line of the administration. So I was really in a gloomy mood at that point towards the late morning, because I had a problem that how to win enthusiastic support of my administration to introduce AI at my hospital. So with that state of mind, I came to Subtle's Lunch and Learn session that year. And I was sitting in the audience just like you are, and minding my own business and eating my lunch. In fact, I was so gloomy that I remember I wanted to eat a lot. And so I had grabbed 2 bags of lunch and poured them into 1 bag. And I was, and I was not paying much attention, just like probably some of you today. But then one of the speakers said something that really struck a note in me. It was like the eureka moment for me, if you will. I realized that there is indeed a strategy which I could deploy to bring AI to my community hospital and persuade the administration to get it. So what was it that was said that day that caused me to become optimistic suddenly? Well, it is best depicted in this flow chart, which is the imaging flow chart, which shows you the various steps involved in imaging, in medical imaging, starting at scanner, going through image acquisition, enhancement, and then finally diagnosis by the radiologist. What the speaker said back in 2018 is that most of the time when we radiologists talk and hear about AI applications, they are to help the radiologist. But he pointed out that in fact, Subtle Medical's AI application work at a much earlier step. We can use Subtle's AI products to denoise the images and to improve the resolution of the images. Now we get really noisy images with poor resolution when we use short acquisition time. On the other hand, if we use long acquisition time, it reduces the scanner throughput, and it makes the patient more uncomfortable because they are on the scanner for longer time. So I realized that Subtle AI products can be used to increase the throughput and make the patient more comfortable. So I decided that to start with, I should go for the non-interpretive AI applications, which will please the 3 stakeholders, and then hope that they will support in the future interpretive AI. So we quickly realized that there are 2 areas in which there is a problem with acquisition time because they are very long. So one is the PET-CT acquisition, and the other is MRI scans. They both have the same problem. The acquisition time is long, patients become uncomfortable. There is patient motion artifact, which is something that we don't like as radiologists, and there is decreased scanner throughput, which the administration doesn't like. So we realized that SubtlePET and SubtleMR would enable us to increase the throughput, which the administration would like and care about, optimize the workflow, and directly impact the patient comfort. This is just an implementation flow diagram. And this, by the way, was one of the pleasant surprises, because coming from a small institution, I was worried that implementation will require a large team of IT experts and a lot of software and hardware and so on and so forth. But implementation was very smooth, very fast, and did not require much time at all. So the images are obtained on the scanner, they are sent to Subtle via cloud, they come back to us, and they are sent to PACS. There was no disruption of workflow, and the whole process works with all different guidance of MRI scanners. So starting with the implementation of SubtlePET in October 2019, and then subsequently with MR in October of 2020, we have done lots of patients. Actually, the numbers currently are much higher than these. So this is an example of the old protocol where we used to take 24 minutes to acquire a complete PET scan. Now we acquire it with about 4.5 to 5.5 minutes, and then they are enhanced by SubtleAI, and these are the images which are as diagnostic as the original scan. This slide just shows you the fact that the SUV values between the old protocol with the 24-minute acquisition are within plus minus 10% of the SubtlePET. This slide is just to indicate the fact that even if you have a large body habitus patient, the subtle images are as diagnostic. So we conducted a patient survey to make sure that what we were thinking would happen actually is happening. And the patients all responded that they were aware of the fact that their scans now were taking much shorter period of time and they were much more comfortable. That was to the liking of the administration also, by the way. So we also introduced SubtleMR. You have already heard a great deal about SubtleMR from the previous speakers, so I'm not going to spend much time on that, except to tell you that despite being a small institution, we were able to implement it without any problem. So we used for brain to improve SNR by decreasing the number of averages from 2 to 1, and then enhancing them. This image looks exactly like that. So I'm just going to run through these slides because you have already heard a lot about, also we used it for C-spine and then L-spine. So this is the table that we created, which shows, for example, that a brain MRI without contrast used to take 16 minutes and 31 seconds, and now it takes 9 minutes and 59 seconds, and so on for all the other exams as well. So we saved approximately 75% of the time, acquisition time in PET, and we saved about 30 to 50% acquisition time for MRI. And it made the patients happy because they were more comfortable. It made us radiologists happy because there were fewer motion artifacts. And of course, it was appreciated by the administration because it increased the throughput. This is just a case study that I just published in the Journal of American College of Radiology this month, which summarizes what I've just told you. And I called it the contrarian approach because we started with non-interpretive AI as compared to most places which start with interpretive AI. Thank you for your attention.
Thank you very much for that very interesting and thoughtful presentation for integrating AI into your setting. Our next speaker is Krissa Paraskivopoulou. Please help me out. Thank you. She is responsible for group dose management and radiation protection at Affidea. She's senior medical physics and radiation protection expert in the field of diagnostic and interventional imaging, nuclear medicine, and radiation therapy. She hails from the School of Medicine of the National and Kapodistrian University of Athens. How did that work out? Was that all right?
Yeah.
Okay. And we look forward.
Use all the Greek speakers.
There you go. That sounds good. And she's going to talk to us about the use of subtle technology in positron emission tomography.
Thank you. So thank you for inviting me to share our experience with SubtlePET in Affidea. So how does this work? Yeah, okay. Affidea is the leading pan-European provider of advanced diagnostic imaging, outpatient and cancer care, with a unique network of centers. So we are present in 15 countries with 312 centers. We offer our services to 10 million patients per year, and we perform something like 20 million examinations annually. Okay, why? We have a little bit less than 1,500 diagnostic and cancer imaging equipment and 16 PET-CT scanners. We are committed to quality, and this is the reason why all our PET-CT centers are accredited by the UEMS EBNM organization, and the majority holds a NERL certificate. On a European level, the Affidea centers represent 60% of the accredited ones from the UEMS EBNM. And our clinical practices are driven by innovation, and we have a robust methodology for clinical validation and commercialization of artificial intelligence products. We perform 20 million scans per year, so we have a lot of data, and we have tools for data annotation and anonymization. We are present in 15 countries, which is a big benefit. It's a multi-payer market. And we have a highly experienced multifunction innovation and clinical business development team. So our methodology consists of these 9 steps. First, we have selection criteria for AI solutions. We have legal review, solution architecture review, including digital infrastructure for the solution integration. We define key performance indicators. We do clinical and technical assessment. We train our healthcare professionals. We do clinical workflow assessment and integration. We have a commercialization process, and of course, a communication strategy and preparation of the information for the stakeholders. So Affidea and SubtlePET started a strategic partnership, and we are very happy for this because we maintained our standard of diagnostic quality while having patient safety at core. We reduced the administered FDG dose and enhanced patients' comfort because we reduced the time on the PET scanner. We improved our efficiency, like everybody said, because now we have reduced waiting times and we increased our PET-CT capacity. And last but not least, we optimized our cost with rationalizing the FDG doses that we were ordering. This collaboration started with Affidea IRMED in Torino. with Affidea on Coincide, a clinical service offered to patients undergoing PET for follow-up of cancer metastasis. So with the help of this artificial intelligence tool, we enable the reduction of dose of up to 33% and up to 2 times faster scan acquisition time for the same diagnostic outcome. OncoSite started in Italy, and it's now live in our centers in Poland and Romania, in 3 countries. So how all this started? We started asking some questions. So can we maintain the diagnostic confidence by reducing the FDG administered dose by 1/3 of the standard one, and use SubtlePET to get the same diagnostic image quality? What if we reduce the acquisition time, 25% or 50%? I heard 75%. We haven't tried that yet. Can we reduce both dose and scan time? And if we can do all this, is this reproducible to all PET-CT scanners and models? So what we achieved? We ran a 3-phase study. We started by reducing the dose by 33%, with 60 patients participating, 10 pathologists and 3 different scanners. That was phase 1. Then we reduced only the time, keeping the dose administered at the same. Again, 60 patients, 50% scan time reduction. And the 3rd phase, we reduced both dose and scan time. And our question was, can we maintain diagnostic accuracy for images? So this is a patient participating in the 1st phase of the study with reduced dose. This patient was referred to IRMET for assessing for restaging after systemic disease. You can see here the liver. Image B represents the native scan, a normal scan, normal dose, normal acquisition time. Image A is the one with the reduced dose. And you can see that there are some extra focal metastases, maybe. According to image B, which is the native scan, this patient had a stable disease. But if we took the one with a reduced dose, you might think that there might be more metastases. You have progress of the disease. And image C is the processed image with SubtlePET. And according to our doctors, image B and C have the same image quality. There's no inferiority of the processed image. So we published our work in the European Journal of Nuclear Medicine and Molecular Imaging Physics. And this is the first real-world study that demonstrates the non-inferiority of artificial intelligence processed FDG PET-CT examinations obtained with 2/3 of the administered dose, and a methodology to define an AI solution commercialization. Now, phase 2 and 3, I just to remind you, phase 2 is just reducing the time. We saw no differences in the final lesion detection or in the image quality. And phase 3, we reduced the dose by 33% and 25% the time. And again, there were no differences between the image quality of the native scans and the process scans. Look into the future. Our first step is to roll out SubtlePET in the group network, all our PET-CTs. We are currently running phase 4, reduced dose and time with a digital PET-CT. 20 patients will be assessed with reduced time and 20 patients with a reduced dose. And SubtlePET phase 5, I'm happy that I heard for the new tracers. We want to test with Colile, PSMA, and gallium tautotoc. So in conclusion, this innovative partnership with Subtle Medical allowed us to enhance patient safety. You know, I'm a medical physicist. I really like to hear that, well, we cut the costs and patient comfort, but I'm very happy that we are able to reduce the dose that we give to our patients that are usually having many of those examinations, especially for restaging. We maintained our image quality, which is also very important, but we also improved our operational efficiency. And of course, we have a lot of benefits, cost benefits, which gives us a competitive advantage. Thank you so much.
So your speakers did a wonderful job following the rules and staying on schedule. So we actually have some time for questions. I'll ask one, but I think we have almost 10 minutes for questions from the audience. So, you know, I can't do it from memory. I'm so sorry. But your presentation was very, very impressive in showing us that noise can mimic pathology. That was absolutely shocking to me to see those things looking so much like lesions. And it really illustrates a principle that applies across the board, is when our images aren't the quality that we need, we can often go astray. So I think that's really important. Dr. Doshi also mentioned that he had his system set up on the edge. So it didn't need to go to the cloud, didn't need to come back. But I can tell you, and I imagine you're wondering, gee, what is the workflow like from the cloud? Well, I can tell you, you know, anybody who knows me knows I'm an MR geek. I like to sit at the scanner, and I like to work on protocols, and I've assisted in some of the design of the things we've done at RadNet. Sitting there at the scanner, doing protocols, checking, doing, I had absolutely no lag whatsoever. The scans basically come down and are ready to read in about a minute, which frankly boggles my mind that you can do it that way, but that's actually the way things work. So it really does follow the workflow that you need. So are there any questions for any of our speakers? Yes, please, go ahead. If you could stand up, I'll repeat your question if it doesn't come through. Actually, if you can come to the microphone, that'd be great. Is the mic live, guys? Yes, thank you.
Hey, thank you very much. Those were great presentations. I'm Dr. Shroff from Hospital for Sick Children, University of Toronto.
Would you mind, if you wouldn't mind taking your mask down, because you know I'm old. I have old ears. Now I see an old friend, so I can recognize you now.
Thank you for the presentations, and great to see the progress. So I'm Manu Shroff from the University of Toronto, and I worked on and collaborated with the SubtleIR group on pediatric patients, MR and PET-CT. So glad to see Health Canada approval. But my question is, in Canada and many institutions, data cannot leave the institution to go anywhere to get processed. So how do you deal with that? Do you have real-time processing with in-house servers like you showed? Somebody showed an in-house server, and how do we deal with that?
Okay, so I missed the beginning part of the dilemma. Was it about you can't use the cloud? Was that what you were saying? You have to be on campus?
Privacy rules, particularly for data leaving Canada to go to USA for processing, or even leaving an institution like the hospital itself to go and get processed somewhere and come back. How do we deal with that?
All right, so I told you how well it works for me in the cloud. Dr. Doshi, why don't you come up and answer the question from your perspective on the edge?
It works very well. You know, the issue is you have to have the servers, right? So, I mean, each server can only handle so much. Now, the Subtle people can, I can't talk to you from the IT perspective of what the specs are and things like that, but, you know, we have one server that was running 2 scanners, and then we added another server to handle 4. Okay, so it's really one, that was kind of my understanding. I'm sure, you know, they'll be able to tell you more about that. But the on-prem solution is totally viable. You know, if your cloud-based solution is not an option, like what you're saying, or difficult. And we've been using that, and it's been working very well for us. There's really no lag. You know, and one thing to remember is that you're not getting the raw images over, so it's like, oh, I'm starting to read it comes over when it comes over, when it's all processed, right? So if you convert it completely over, when you get the images, that's the images that you're looking at to read the scan. You know, you're not waiting for, whatever the lag is, you're not really experiencing, because you're reading cases as you go down the list, and when you pop up in a case with subtle images, that's what's coming over.
Thank you.
No.
Thank you. You know, in RadNet, we have, I think, 3 data centers for the entire company. We have 353 centers and some 300 MR scanners, and who knows how many CTs, and who knows how many PETs. So it works in that way as well. So it's essentially, you know, in our cloud, not in the big cloud. Dr. Feller.
Yeah, just a question on the SubtleMR in terms of the validation of quantitative techniques. So we've seen some variability, for example, in our prostate MRI, the ADC calculations kind of with Subtle versus without Subtle, and just, where those validation studies are at with regard to that, and things like, velocities on phase contrast angiography or T2 values on T2 mapping, so the quantitative part.
Well, it's a very interesting question. It has been shown that deep learning techniques maintain the integrity of things like fractional anisotropy. Dr. Bass showed that it maintained the integrity of, lobar brain measurements, as well as the clinical assessment of disease. So there was two measures there, the numbers as well as the clinical characterization of disease. But you're right, more studies need to be done. The problem is that if you're comparing a low noise image to a high noise image in terms of getting values, you may be in a circumstance where the numbers may change. But one of the great hallmarks of deep learning reconstruction is the numbers are the same. I'll give you an example in CT. On CT, we all know we went to iterative reconstruction, the Hounsfield numbers changed. Okay, deep learning reconstruction brings those back. So to back where they should be. So there's every hope that it will, but the validation studies need to be done. And you need to do them. Because as you know, you do a hell of a lot of prostate work. It would be very good to have that in your hand. Okay, I think we have time for maybe one or two more questions. Please go ahead.
Hello, I'm Kathleen White. I'm a nuclear medicine physician from France. And I'm very excited to meet you because we were able to also test in our center SubtlePET. And so we obtained very promising results. And first I was wondering how widespread is the use in US and outside US of SubtlePET in a routine clinic. And second, so we obtained very good results, but with minor performance drop in the visual detection accuracy and quantitative measures. Because our native PET images are already very noisy, and we have a low time activity product from the native PET images. So I was wondering how we could further optimize the performance. Could you think about some strategies? Because we are...
Sure, I've got all the answers for you. I got them all right here. So there were two parts to the question. One is how prevalent is in the U.S. And there's at least two people in the room who could step up to the microphone and answer that question for you. You want to handle that? It's all over. So first of all, the best answer to your question, really, I would go to the booth, which is where?
4938 in the AI showcase.
Okay, so have that chat. On the other hand, it does illustrate the principle that we often are suffering with noisy images, regardless of the reason. In RadNet, maybe because we feel compelled to get the exams done faster than they do at the university because we're patient-focused. In your case, you say you have higher noise levels than you like. These are tools that can reduce those noise levels and optimize image quality. But I do think that it is something that, it is worthwhile stopping by and talking to some of their experts. I'm just like you. I'm just a user, fighting the good fight on the street. Okay, we are out of time. So there are some subtle people here. Somebody can come and answer your question. You can come and ask me if you like. But I think we need to kind of clear the room.
I want to ask a question about, is there continuity over time, comparison with exams, like neoadjuvant therapy follow-ups? Is there any directions toward that? Or comparison with a prior exam for higher detection of cancers when you have a comparison?
Those are great questions, and I would follow up with somebody on that topic as well. Thank you to everybody who took the time to do this. Thank you for the speakers for a great and disciplined program. Enjoy the rest of the meeting.